In this session, we will explore about different types of functions in Python. We will start with the regular functions about which you may already be aware. So this can be a refresher for you. We can define regular functions with the define keyword, followed by the function name and parameters in parentheses. This setup allows us to write a block of code that performs a specific task which we can reuse throughout your program. For example, when we write a function to add two numbers, we encapsulate the addition logic inside this function. By calling the function and passing the numbers as arguments, we execute the contained code. Regular functions are crucial for structuring our code, especially for complex operations that need to be repeated in different parts of the application. They are easy to read and debug thanks to their straightforward syntax. However, for straightforward tasks, this approach might seem overly complex. In those cases, Python's Lambda functions offer a more concise solution. Despite the simplicity of lambdas for minor tasks, regular functions are indispensable for building well-organized and efficient code, providing a clear way to manage and execute more involved logic. Lambda functions in Python allow for writing small anonymous functions in a single line using the lambda keyword. They are ideal for simple operations that are easily expressed in a single line, such as quickly transforming or filtering data. For instance, we might use a lambda to square a number or concatenate strings without needing the formality of a regular function. While lambda functions offer concise syntax and are handy for one-liners, their simplicity can be limiting for more complex logic, making them less suitable for tasks requiring multiple steps or conditions. Nonetheless, they are a powerful tool for inline operations, particularly in combination with functions like map and filter, and they enhance code brevity and readability for straightforward tasks. Generator functions in Python, defined with the define keyword and using the yield statement, enable the creation of iterators that lazily generate values on demand. This feature is invaluable for working with large data sets or infinite sequences, as it allows for data to be processed incrementally without loading everything into memory at once. A generator could be used to create an infinite sequence of numbers, providing a stream of data that can be iterated over with much lower memory consumption compared to storing the entire sequence before processing. While generators are efficient and powerful for streaming and processing data in chunks, they introduce complexity and are less intuitive than simple loops or list comprehensions for beginners, or for that matter, use in scenarios where data size is not a concern. Recursive functions in Python, which call themselves with their definition, are a natural fit for problems that can be broken down into smaller and similar problems. They are commonly used in algorithms that involve nested structures or operations that can be divided into simpler identical tasks like calculating factorials or traversing directories. Recursive functions simplify the code for such tasks, making it more readable and elegant. However, they can also lead to performance issues and Stack Overflow errors if not defined carefully, especially for deep recursion or when the termination condition is not well defined. Their use requires a balance between elegance and efficiency, with iterative solutions sometimes being preferable for performance critical applications. Higher order functions in Python are functions that can take other functions as arguments or return them as results. This capability is central to functional programming styles, allowing for flexible code that can abstract or generalize operations over data, such as applying a function to all elements of a list or accumulating results. Higher order functions like map, filter, and reduce enable concise and expressive data processing pipelines. They can greatly enhance code modularity and reusability, but may also introduce complexity and make debugging more challenging due to the additional layer of abstraction they provide. Nested functions in Python are functions defined inside other functions. They are useful for encapsulating logic that does not need to be exposed globally. They can leverage variables from the enclosing scope, enabling more compact and maintainable code structures, especially for complex algorithms that require multiple steps of processing with shared state or context. Nested functions enhance code clarity and locality of logic, but can make the overall structure harder to follow if overused or when dealing with deeply nested definitions, potentially impacting readability and even maintainability. Methods are functions attached to objects in Python defined within a class. They operate on the instances of the class using the data and attributes associated with those instances. Methods are fundamental to object-oriented programming, allowing for behaviors that interact with an object state. They enable encapsulation and interface definition, making code more modular and easier to understand in the context of objects it manipulates. However, methods are tightly coupled to their classes, limiting their reuse outside the object-oriented design and potentially complicating the code base if not well organized. Built-in functions are readily available in Python's standard library, providing essential functionality without the need for explicit definition. Functions like print, len, and range are examples that offer convenience and efficiency, optimized for performance and designed to cover common programming needs. These functions are a cornerstone of Python programming, significantly reducing the amount of code required for basic operations and ensuring consistent, reliable behavior across different parts of a program. While highly useful, their fixed behavior means they may not always fit specialized needs, sometimes necessitating custom solutions for more complex or domain specific tasks.